Today we're going to talk about derivatives and how derivatives relate to inverse functions. So we're going to do a quick review here, just remind ourselves what inverse functions are. This is something we covered way back in chapter 0, but it's been a while. So the thing at the right over there has f of x, right, which is this graph right here. I'll outline it in red. There's f of x, and then we have g of x, which is this graph right there. Just a reminder, so if they're inverses, if f of x has a point AB, that means g of x, right, point AB, that means g of x has a point BA. With inverses, all you're doing is taking the domain and range, and they're switching. So the x's and the y's are just being switched. They also reflect across that line y equals x. So in the book here, it's going to refer to what it says as image points. The image points are the points that are reflected across from each other. So those two would be image points, or if I chose a point here, its image point would be right there. So they're those points that are symmetric across that line, y equals x. It says from the graphs, do you see the relationship between the slope of the graph of f at AB? So here's the AB. Think about what the slope would be right there, and the slope of the graph at BA. Well, there is a connection, and that's what this lesson is all about, is finding that connection. Let's run through this really quick. This is just an example to help us find that. So it says, sketch the graph of f of x. Well, f of x equals the square root of x. We know that starts at 0, 0, another point at 1, 1. There'd be a point at 4, 2. Right? It's like that. Sideways, half of a sideways parabola. That's what f of x looks like, something like that. B says, find the inverse. So a couple things. Make sure you recognize on f of x up here that the domain is x is greater than or equal to 0, and the range is also y is greater than or equal to 0. It says on part B, it says, hint, you must do a domain restriction. We're going to use this, the domain and range of the original function f of x, to find the restriction on its inverse. Okay, just a reminder how to find the inverse, right? We replace the f of x with y. And remember what we just said, inverse functions, you switch the x and the y. So we're going to switch those around. X equals square root of y, and now solve for y. So I'd square both sides. So I get x squared equals y. So we would say the inverse of f of x equals x squared. Here's the thing. We know what x squared looks like. It's a parabola, right? It starts 0, 0, 1, 1, and it curves up that way. But there's also another half to the graph. If you looked at just the right side, all the way to there, it looks like the inverse, right? We could draw the line y equals x, and it reflects across that. If I add the left side, it doesn't anymore. We'll look up at the original problem. On the original problem, we said the range was y is greater than or equal to 0. If we switch the x's and y's then, that down here, that makes the domain of this one is x is greater than or equal to 0. So all I'm doing is looking at the right side of the graph. I'm starting when x is 0 and just going to the right. So that's our domain restriction. Okay, so now I have the graph of f. I have the graph of its inverse. I just sketched it on the same coordinate plane there. Then it says take the derivative of both. So let's start by taking the derivative of f of x. These are both pretty easy to take. Right, f of x is x to the 1/2 power. So when I take the derivative, it's going to equal 1/2 x to the negative 1/2, which you could write this way if you wanted, right? That'd be 1 over 2 square root of x. Okay, let's take the derivative of the inverse. This gets the symbolism here gets a little crazy, but right, I'm finding the derivative of the inverse. That's what it would look like. It's just x squared, so it would just be 2x. Okay, it says find the slope of the graph of f of x at 4, 2. So I'm plugging 4 in for x. So come up to my derivative. We're going to plug 4 in for x right there. It'd be 1 over 2 square root of 4. Square root of 4 is 2. 2 times 2 is 4. So f prime of 4 came out to be 1/4. Okay, and then it wants me to find the slope at its, and notice that this point is 4, 2. This is its image point at 2, 4. Right? 4, 2 is here. 4, 2 is there. If they're reflected across that line y equals x are the image points. So let's plug 2 in there. So I'm going to go I'm going to say the derivative of the inverse. That's supposed to be the inverse. Sorry, my board's being weird. derivative of the inverse, supposed to be a 1 there, is at 2, and having some issues here, at 2 is equal to, let's plug 2 into here. 2 times 2 is 4. So I want you to notice I got 1/4 there, and its image point I got a positive 4. So at their image points, those points that are reflected across the line, my slopes came out to be the reciprocals. So I want to remind you really quick why that might be true. Remember that slope is the change in y over the change in x. Well, if I find the inverse, I take all the x's and I switch them with the y's. So doesn't that make sense that for my inverse, this becomes my change in x, and this becomes my change in y? They end up being reciprocals, right? The one is 1/4, the other one is 4. And that's really what this lesson is all about. If you know that, then you have it. So here's like the rules written out algebraically. It says if AB is a point on F, then BA, its image point, is a point on the inverse. Then if I plug the x coordinate of the image point into the inverse, it is the reciprocal of, if I plug the x coordinate of the other image point into the function. They're reciprocals of each other. There's another way to say it. If f and g are inverses, then g prime of x, the derivative of g, is the reciprocal of f prime, and g is just the y coordinate of this point up here. That's a little confusing, but again, that's all it's saying in the end is what it says at the very end here, is derivative of inverse functions have reciprocal slopes at image points. Remember, we're talking about image points. They're points that are reflected across that line y equals x. Really, you're just switching the x and the y coordinate. Probably the biggest mistake made is what it's talking about in this note right here, which says when you're finding derivatives of inverse functions, you do not use the same x value for f and for the inverse of f. That almost never works. The only time it would work is if your two coordinates had the same x and y, like 2, 2, or 3, 3. In other words, if I look at the image point on 5, 6 in f prime to find my slope, then when I go to do it with the inverse, the derivative of the inverse, I'm not going to plug 5 in. I have to switch that point around. I'm going to plug 6 in. So you got to make sure that it's the image point that the x and y's are switched. One thing that can help you with that is making a table, and I'll show you how to do that right now. So here's this problem up above that says, let f and g be inverse functions such that f has the function and derivative values as shown in the table. So we've got that table over there. Now it wants me to answer all these questions about g, g primed. So to do that, if you fill out this table, it's really helpful. So if you look up here, when I plug -1 into f, I get 1. So that my point is -1, 1. And at that point, the derivative, or the slope, is 3/2. If I plug 0 in, I get 2. And the slope when x is 0 is a positive 2. If I plug 1 in, I get 5. And the slope there is a 1/2. So it doesn't give me any information about g, but if I list all the information about f, the point and the slope, I can get all the information about g because it tells us they're inverses, right? Those two are inverses. So if f has a point -1, 1, g has a point 1, -1. And if it has a slope of 3/2, it has a slope of 2/3. If f has a point 0, 2, g has to have the point 2, 0. It has a slope of 2 at that point, so g has to have a slope of 1/2 at that point. Instead of 5, 1, 1, 5, it'd be 5, 1. And if it has a slope of 1/2, that one would have a slope of 2. Now we're going to use this information over here that we just got about g. We used f to find this information because they're inverses. Now we're going to use this information about g to find it. So g prime of 1, well, when I plug 1 into g, my slope is 2/3. G prime of 2, if I plug 2 into g, I get a slope of 1/2. Okay, g prime of 3. Well, here's the problem. To find g prime of 3, I'd have to have an x coordinate with a 3 in it, and we don't have that. So in this case, it's not possible with the information we have. There's not enough information here. G prime of 0. Again, there's no points. I don't have any points where x is 0 on g, so not possible. Not enough information. G prime of 5. I do have that. When x is 5 and I plug into g, my slope is 2. So what you have to avoid is this. A lot of times we do this problem right here, g prime of 0, and we look up and say, hey, if x is 0, the slope of f prime is 2, so when x is 0, the slope of g prime is a half. The problem with that is that you're plugging 0 into both g and f, and you can't do that. They have to be those image points. Right? So at the point 0, 2, it has to be the point 2, 0. It has to be 2 I plug in, not 0. That's the trickiest part. This is one of those things a lot of times that we struggle with at the beginning, but once we get it, most of us find this pretty easy, but it does sometimes take a little bit for it to click in our brain. Let's do this last example. It says if f of 3 equals 28, where f of x equals x cubed minus 2x plus 7, find the derivative of the inverse of f at 28. So we can do like a mini table here. Let's start with just f of x. So it gives us a point, 328. Let's find the slope of the derivative of that point. So I need to find the derivative to do that. So f prime of x would equal 3x squared minus 2. So let's plug 3 into that. F prime of 3 equals 3 squared is 9 times 3 is 27 minus 2 is 25. So at the point 328, the derivative is equal to 25. The slope is 25. Okay, over here, let's use that now to find the inverse. Sorry, not f prime of x, but the inverse. The derivative of the inverse. I'm just going to leave it as, sorry. Let me try it one more time. I'm just going to leave it as the inverse of f of x. Okay, well, what do we know? Well, if this one has a point 328, this one has to have the point 28.3. This one has a slope of 25, so this one would have to have the slope take the reciprocal of 1 over 25. So the question is, what is the derivative of the inverse at 28? Well, the derivative of the inverse at 28 is the slope. It's 1/25. And that's my answer right there. So the nice thing about these is compared to those related rates or the implicit differentiation sections that we just did, there is a lot less work required. But it can be a little bit tricky. Sometimes we struggle a little bit with wrapping our minds around this. But with practice, this is something that we are all going to, I'm confident this is something we're all going to do awesome on the test. So anyway, appreciate you listening. Good luck. Talk to you later.